Welcome back. My name is Casey Kepley. You're tuning into draftingtutorials.com. Today's lesson is on graphic analysis again, and we're dealing with labeling or vein, which deals with geographical measurements. And when it comes to planes, you'll see this a lot in like the mining engineering process. So, getting started here. Basically what you would have is two different shapes here, two different planes, like seen in the picture here. You got to find a true length line, so you draw your line over here in the frontal plane so that it's parallel to the reference plane, and then draw straight up and over, and that gives you your true length line. Now what you have to do is draw a line perpendicular to the true length line to get your horizontal plane, which is right here. So that's how they got that. That's perpendicular to this true length line. Then you extend your lines out. You've got two different points here in this example. One is the top of the ground, and then one is bottom of the vein. So what you do is you just draw your points out, given the distance from here to here. That's going to be the same distance from the reference plane over. And you'll notice on this one we've got a vertical distance, horizontal distance right here, and a shortest distance, which is perpendicular to the it's perpendicular to the plane, which is in yellow. So given all that, we'll go over here to the lesson that we had in our lab. So we had to draw a true length line. We drew over from here on up. This is our true length line. And I'll go ahead and label that real quick because a lot of times in our labs they have us label stuff. So this is my true length line right here, and you'll notice there's a point right here, point A. Well, point A just simply transfers up, but before you can transfer this point up, you got to get your horizontal reference plane going. So you need to draw a perpendicular line to the true length line. That's this line here. Alright, and then you have to take your distances from back here on the frontal plane for your points, because the rule of thumb is when you're doing your distances on your edge views like this, it's always 3 views back and 2 reference planes back. So we got 1 view, 2 view, 3 views, and 1 reference plane, 2 reference planes. So we're using these distances right here to get our distance up here. So 0.1, 0.3, and 0.2. And once you get those points lined up, then you just draw a line across, and that is your edge view. Now from your edge view, you have to determine your horizontal distance, your shortest distance, transfer your point A up, and get your vertical distance going. So the easiest way to do that is to draw out your horizontal distance first. So you're going to copy this reference plane line because it would be parallel, and you just move the base of it up here to where point 2 is, and then with that line being longer than the one that you see here, this line here is longer, you just leave it that length for the time being and draw your point A on up. So your point A is going to be perpendicular as well to the horizontal plane, and you just lengthen that out with the lengthen command until it intersects your horizontal reference plane, and that point at which it intersects is point A. And then from there you can move, you can change the length of this horizontal distance. so that it fits accordingly. That's your horizontal distance. Your shortest distance is simply a perpendicular line from the horizontal distance. So perpendicular, just straight up and down, and wherever it intersects there with your edge view line, that's the length of your shortest distance. Your vertical distance is right here. That would be perpendicular as well to your horizontal distance. It's going to intersect right there at point A and the horizontal distance. Just draw it straight up to where it intersects with your edge view. And then we'll go back here real quick because well, let's see here. Yeah, that's going to be your shortest distance. We measured this one too to determine which was the shortest distance. Sorry, I had to go back to my notes there just to see what I was looking at here with point A going on up to the edge view line. So you got horizontal, shortest distance, vertical distance. And as you can see here, of these two lines, the reason why we went with shortest distance, the length here is 5.2285. The length there is 4.1836, so that would be your shortest distance. That's why we labeled it SD. And then from there you can fill in your earth design here on the top. The other thing that they wanted in this lab, or the instructor wanted in this lab, was the strike and dip. So strike, just to let you know, strike is always going to be an angle measurement in azimuth, so it's degrees and minutes. And you're always going to have like a north or a south, east-west on one part of the degrees measurements, and then the same for your minutes. And how to determine the strike, you just take your north compass bearing, measure that to your true length line, and that is your measurement right there. 39 degrees, 44 minutes for your strike. Dip, on the other hand, is just the angle. So let's see here. I'm trying to remember how we got that. No, it wasn't there. Okay, so dip is going to be, if you took this line here and just lengthen it out, which would be your compass bearing. If we lengthen it out there and then we measure from there to here, let's get this. Man, where did we get that? Oh, I'm sorry guys. Dip, you just do the slope angle, so it would be from here to here, 3651, and then you have to determine the direction of your dip. So we got the dip from your edge view, slope angle, and then the direction is going to be from your compass bearing, which is north here, and taking your horizontal line, copying it, and just pasting it down here where it intersects with the bearing. That's how you get your dip direction. And so your dip direction, if you were looking at a compass, you got north up here, south down here, east over here, and west over in this section. So our direction is southeast. So it's south and then east. That's how we got the dip direction on that. That's all I have for today's lesson on vertical distance, horizontal distance, and labeling an ore vein. If you have any questions or concerns, I guess you can leave comments in the comments section. But this is pretty straightforward, coming directly from a lab within my class that I'm taking on graphic analysis. You can also subscribe to the channel. I've got videos that I'm constantly updating, just so I can keep up with the progress of the learning process. So I'll have a reference guide to go to at a later point. But other than that, that's all I have for today. You guys take care.